Hello, how are you? It's great to it's great to be back 2 years after. Real people, human beings in a conference. It feels so weird. I yeah, it's horrible when you see only people in this screen. Sometimes you start speaking, the connection drops, and then you never notice that nobody's listening. But anyway, I'm Ricardo. I work for the Chrome OS kernel camera team. That's a mouthful. But basically, I work. I try to make your cameras work for when you are doing video conferences or something when you are using Chrome OS. And yeah, I want to talk about the kernel that we use in Chrome OS. And yeah, so what is the kernel? What is Chrome OS kernel? Well, it's pretty simple. We only use upstream kernel. And yeah, that's it. Any questions? I mean, the only way my boss will pay me the trip is if I made a presentation, so I guess that's it. So yeah, no. Unfortunately, it's true. It's almost true. That's what we want, but we are not there yet, and we want to be there. I mean, if in some years from now I come here and I make these presentations, that means we have succeeded in my team, or not only my team, in the whole Chrome OS team. But unfortunately, we are not there yet. So yeah, Chrome OS, Chromebooks. What is a Chromebook? Well, if you ask anybody outside this room, this is what they will think when they think of a Chromebook. So first of all, when they go to El Gigante or whatever you have in Sweden, it's one of the cheap ones. It's not the most expensive one. It doesn't have any piece of fruit in the other side that makes it more expensive. It's relatively cheap, but it's not only that. You'll get 8 years of security updates. So you buy it, and in the next 8 years, you will not have any meltdown or something like that affecting your computer. And it's like the Rosetta Stone of consumer notebooks, because you can run not only Linux apps, but you can also run Android, Linux, and Chrome OS apps. Chrome OS apps is basically PWAs. It's simple applications that are run inside Chrome OS. It's very limited. The ecosystem is relatively limited, but we leverage a lot from Android and Linux. So suddenly you have a very good ecosystem of applications. And it's quite power efficient compared to other products. You can use it, leave it in your desk. Next night you open it, still the battery is almost at the same level as it was the previous day, and you can use it for the whole week on your bed, or you can rely. You can put it on your backpack, and you don't have to think constantly about the battery. So in the paper, it's a nice notebook. But for us, I mean, do we care when we look for a Chromebook? So first of all, we need to understand that a Chromebook is not just a product that a company makes and installs operating system called Chrome OS. No, a Chromebook is something that is developed hand by hand between a manufacturer and Google. And it's both logos you will see on the notebook, which means we have both responsibility on this product. We are proud of it. I will I will behave. Don't worry. Yeah, so we are both proud of it, and we want to deliver the best. It runs by default the Chrome OS Linux distribution, but that is it. It runs a distribution. We can run something else. Doesn't mean you have to use Chrome OS by default. It's just another distro you can run. But of course, that's the one when you open your notebook you will firstly see, because yeah, that's what our clients buy it for. And it's using a custom kernel. It has it's an off-the-shelf architecture. We didn't invent the wheel here. We didn't have any fancy computer architecture. It's x86, it's ARM. It's nothing fancy, with some extra hardware features. But they are not super fancy. I mean, they are great, but it's not a revolution. We have an easy an embedded controller which is taking care of security and power management. And we have a USB-C with debugging capabilities. It has an embedded serial port, and it will help you to use your notebook for developing fancy things. And we have some extra security features which guarantees that if you run your Android applications, they are safe and they are exactly the same as the developer has created. And you cannot steal your Netflix movies. You cannot just download them. If you want Netflix in your platform, you need to provide some security. We use Coreboot as our bootloader, which is great if you are not very fan of UEFI. It has also helped a lot pushing the vendors to release more information about their architecture, about their boot process. It's not a black box anymore. Coreboot is much more open. And it's available, as I said, in multiple arches, so you can have ARM, you can have Intel. And it's built with Portage. I don't know how many fans of Gen 2 are here. Oh yeah. You will love it because we build it using Portage. And as a developer, this is the two things that you will mainly see. That's a SUSI cable and that's and the SDK, and that's where it's built. So I just said it's a standard architecture. So why we don't have a vanilla kernel? Well, so these are the reasons. First is we are doing a very aggressive power saving. We are working with hardware that is not released yet. And because we are bringing it up, we are experimenting, and maybe the software drivers are not yet ready for the release, so we need to work on them. We have also some drivers which are downstream because sometimes we fail, and we fail to make our vendors understand that upstream is the only way, and for maybe some reasons, for some period of time, they will be downstream. We also have some configuration files in the tree, so our config is there. That is nice. That is something I like because you can see the specific config for your platform in that specific snapshot of your kernel. So yeah, we also have some build system and review tool files in our tree. That's the author file. That's something that tells Gerrit who is the owner and of the thing, and which checks do you want to run before you upload the patches. I said we support Android. The downside of supporting Android is that Android relies on some features in the kernel that are not standard, so we need to support those features. We also have some platforms which are using old kernels, and we want to maintain a stable kernel until uprep. Uprep is the word that we use for updating the kernel to the new version. But to be honest, this sounds to me like excuses, and they are. And we are working to fix those, to fix this. And we have plans for everything. So for aggressive power saving, upstream it. Yeah, we are really investing a lot of time and effort in upstreaming it, and it's in our plan. We don't want to maintain anything ourselves. We are working really hard with our vendors. We go hand by hand, and sometimes we stretch their hand as much as possible to say, yeah, if you don't upstream it, then we are not going to accept this platform, or because that's the way we do it. For the drivers that are downstream because the kernel doesn't have the features that our vendors need, we are pushing new initiatives. And that's something we are working not only with our vendors, but also with upstream. And if you go in 2 weeks from now to the kernel recipes, you will see a very good example of this. For the build and review system tools, that's simple. We just get the files and put it somewhere. It's just a technical solution. That I'm not too worried. Android features, we already have the solution. It's called ArcVM, which means that instead of running Android directly on the hardware, we'll run it inside a virtual machine. So yeah, problem solved. For the platform using all kernels, we uprep. We constantly are upreving our platforms to the newest kernels. So that is solved. And to maintain a stable kernel until we do this uprep, what we do is a very, very, very aggressive testing. There's thousands of machines that are testing and different notebooks that are testing everything before we move forward. And because the amount of lines of code that are in the kernel every day in every version, that's really the only way. You need to test everything and you need to test it thoroughly. How far are we? Well, these bars are telling you how many patches we have in the kernel, in our kernel, that are not coming from Linux. And it's, yeah, if you see the media, it's quite ironic because the person telling you about upstream and how good upstream is the main responsible or the one to blame for why we are not upstream Linux. But we have a plan for that. You see those fancy colors, and it's because we tag the changes we put in our kernel. So if you go into our source repository, which because everything is there, all the code is available for you. You can pick at it. We have tags. So when we make a patch, we put a tag. And I think this is a really good idea. If you are not doing something similar, I think you should do something like this. We have these different categories for patches. Chromium, which is the worst, is that things that are not going, we are not going to attempt to upstream. From list is a patch that we have sent to a mailing list for review, and then we take it in our kernel because we need it for, we need to release a product, and the product needs to reach the market tomorrow in a week. From JIT is a patch that after being in a mailing list is now in the branch of a maintainer. So it has reached the SSD subsystem, the camera, the multimedia. Upstream is a patch that we take from a next version of the kernel and we backport it without any change. And backport is exactly the same, the blue one, but we make a modification on the file. So I don't know, for whatever reason we didn't manage to backport it cleanly, and yeah, we have to make some changes. And those are the main tags. So when we send a patch to Gerrit, this is how it looks. The main part is the first thing you will see is the first tag I was telling you about, the from Git. But then we also have some extra tags. The other tag, which is the two other tags which are important, are the bug and test. Bug, it's in which in our internal bug analyzer, but it's internal, but it's accessible outside. I mean, it's by Google. That is going to tell you why we have this patch and who has worked on the patch and the reason behind the patch, all that. And the second line is test. How are we tested that this thing worked the way we expected? And yeah, there's another, if you are used to Gerrit, there's also some other tags. Change ID, which Linux hates, which is an individual identifier for that specific patch. Here, where you can find this patch in Gerrit, all that. And yeah, I think Gerrit, everybody uses it, suffers this Stockholm syndrome. At the beginning, you hate it, but the more you use it, the more you start to like it. Because it's great for comparing patches, especially when you have to review a lot of patches. So yeah. So yeah, I love it. I want a Chromebook. I want to sell all my Raspberry Pis. I'm going to buy a Chromebook. And how I hack the kernel? So it's pretty simple. The bar for the requirements is very, very low. The only thing you need is QEMU. You build an image, you run QEMU, and you are done. The problem is that this is very boring. I mean, who wants emulators? You want hardware. If something doesn't work, you want something to hit. And if you run QEMU, you're hitting your own computer. So it's not a good idea. Instead of that, you have these requirements, which are also cheapies, and is a SUSI cable, a pen drive, and a Chromebook. SUSI cable is just the cable that is going to enable the debug mode in your Chromebook. Apparently, there was a boat which was trying to cross the canal, stuck in the middle, and since then it's impossible to buy anything from China. And because of that, it's really difficult to get your hands on a SUSI cable right now. They have really good problems manufacturing right now. But it's only a standard USB cable with 3 resistors. So if you're into hardware, you can, if you cannot get one, you can build one yourself. It's relatively easy. Pen drive, I recommend the one from the Linux conference. Or if you try to get the fastest one that you can buy, these SSD-based are really good. And a Chromebook. Which Chromebook? Well, I cannot recommend you one. And it's not because it's forbidden for me to tell you a specific module, it's because I'm completely biased. I'm going to recommend you the one that I have been working with, or the one which have my drivers. And so what I recommend you is you pick your chipset, your favorite chipset. It's a Rockchip, it's a Qualcomm, MediaTek, whatever, or AMD, Intel. Buy it and use it. There's not any reason for choose one Chromebook or another. You're going to be the one deciding, or the cheapest one. You decide. Yeah, so in order to understand how to hack the kernel, we need to know how the kernel is loaded. And that's the boot sequence in Chrome OS, which I was telling you before is based on Chrome boot. It's based on core boot. So first, core boot runs from a flash, and then we run a core boot payload, which is called deep charge, depth charge, which is for Chrome OS. And this payload, what it's doing is verifying that the next part of the code is signed and nobody has mangled with the code, and it's safe to boot it. It's making sure you are not pressing any magic key to boot from a pen drive or to recover your system or things like that. It's also showing you these nice screens when you boot it, and then it's jumping into your kernel. The kernel is placed in a specific partition. We have 2 of them in case one is broken. So yeah, that's what deep charge does. And then this kernel is going to boot the rest of the file system, which is just Linux. You will be surprised how little we have done. Don't tell that to my boss. I tell you deep charge is making sure that the code is not modified, but you want to modify your kernel, right? So that's when you start to become a hacker. In the first Chromebooks, you have to unscrew a screw, and that was telling the device that you were in dev mode. And that was feeling super hacky. But now in the new ones, it's simpler or different. You press 2 buttons, you reboot the machine, and you get a screen saying, hey, you're about to enter dev mode. And it's going to erase all your data in case you saved a Netflix movie. So it's going to be deleted. And from that moment, you are in dev mode. It's going to take some time. And there's an interesting thing of why it takes so much time. So we want to make sure that nobody steals your notebook. So let's say you go through the security, so through the border control, they take your notebook. It's going to take some time before it can be in dev mode. If you will be able to enter dev mode in, say, 10 seconds, the policeman or whoever will be able to install a new OS in your system. You will get it and you will never notice, and then you will enter with your password. And that's why we have to add this extra delay. I think it's 2 minutes. So somebody needs to have physical access to your device for at least 2 minutes to leave the secure mode. So yeah, that's an interesting fact. And then from that moment, security is disabled. So you can run whatever OS, you can run whatever kernel. You're good to go. How to build your kernel? Well, you just can get the kernel from Linux and put it in the partitions, but that's a simpler way, which is downloading the Chrome OS SDK. It's based on repo, the same thing that Android uses. A lot of people don't like it. They have reasons for that. And yeah, you download it, you repo, you do repo sync, which downloads, I think, 1,000 repositories, and then you enter the SDK. The SDK, the way it works is a chroot. So that way we make sure all the developers are using exactly the same environment, and you can, we are not going to break your computer if we make a mistake. So yeah, and then you just choose your device. you do that by running those 2 commands. The second one, what it's doing is building the SDK for your computer. So you need a specific compiler. It's going to build the compiler for yourself, and it's going to set up portage for that specific platform. And yeah, we have developed Chrome OS. This is made by developers. We have a lot of notebooks at home, so it's made so you can switch very easily from one platform to the other. And then you build your kernel. And in order to build your kernel, first you need to tell to Gen2 that you are going to modify your kernel. So please don't override my changes. You do that with the first command, and then you build it. When you build it, you pass that use equal, meaning that means you are enabling the serial port. Serial port is great when you make mistakes, and it doesn't boot, so you really want that. And then you build it. It's going to take a while, but yeah, it happens. Then you install it. Before you install it, you need to mark the partition as you need to remove the root verification. Before, what we did was not caring about if something is verified or not. In this step, what we do is removing the verification. And then with the second command, we update the kernel and we send it to the machine. And yeah, if you want to modify the boot parameters, remember we are not using grab, we are using depth chart. So the way to modify the commands is like that. And this is, again, if you want to use the Chrome OS path, if you want to load Linux as a payload for core boot, you know how to do it. This is just if you want to do the Chrome OS way. And then you debug the errors, right? And debugging the errors, by default in Chrome OS, we have enabled something called PSTOR console. It's a standard, we haven't invented it. What PSTOR console does is that all the D messages are saved into memory. So there's a specific place in memory where it's saved. And it's a persistent storage place in memory, right? The bootloader knows about this specific area. So when it reboots the machine, it's not going to clear this memory. So when we crash, because we have config, panic, on oops enabled, we are going to restart the system restarts, core boot is not going to delete that section, it's going to leave it as it is, and then when you boot, you will be able to go into that directory, and your old DMESC is there. So you will see the oops there, and you will debug what is going on, and yeah, you know, have fun. But those are for the easy errors, right? The ugly ones is where you need a serial port. And we got you covered. You just need a SUSI cable. The SUSI cable is that thing that you just connect your notebook to the Chromebook via USB-C, and suddenly you have 3 serial ports. One is connected to your CPU, the other one is connected to the microcontroller, and the other one is connected to the security chip. And you can change the firmware for the 3 of them. So you have the source code for everything. So, yay! I love it. I'm going to burn my Raspberry Pi, and I'm going to start using Chromebooks. How can I contribute? You don't. I mean, we don't want your patches. Upstream wants your patches, right? If you make a change, we will love those changes to be upstream, because that's where we want our changes to be. We want to fetch things from upstream. But if for some reason your patches don't belong to upstream because they fit into some of the excuses we saw before, you need to go through the Chrome OS path. And the Chrome OS path is you make your changes, you build your patches, you send it through Gerrit. For that you use repo upload. Then you need to wait until somebody from Google or somebody with review review your patch. And then what happens is that your code is sent through many farms full of notebooks, right? And they are going to test your change. So I think we have something like 200 different platforms now we have a big number of devices for each. They are in these farms. Are then going to run your change. Even if it doesn't matter if it's a comment or whatever, it's going to be tested. And yeah, when that finishes, which takes a couple of hours at least, then it will be in our top of 3. It will be in our, it will be part of Chrome OS. And but now you want to know when can you tell your mom that your code is in her notebook, right? It doesn't happen immediately. We have a release cycle. And the release cycle is a 4-week release cycle, meaning that we release something every 4 weeks. But we have something similar-ish to what Debian is doing in terms of releasing things. Your changes are going into top of the tree. This is our master branch. They stay there for at least 2 weeks. That's what we call canary. Then they are upgraded into deb channel. Anyone can install deb channel in their notebook. You go into your properties and you go into deb channel, and then you are in the deb channel. And then it goes into beta. It needs to stay 4 weeks into beta. Every single time, every single week and every single day, everything is tested, and we get reports for when something is failing. After it has been in beta, it will jump into a stable, right? And there's automated tests and human tests involved in that, into all this process. And I think that's all I wanted today. I was speaking too fast. I was excited because coming back from quarantine. So, yay, any questions? And yes, if something I was telling you about make you sprinkle in your stomach, we are hiring, and we need you. And yeah, offices, they look really good. Any questions? Yes.
I've used Chromebooks for a while, and I've not hacking them. I've had them since 2014, I think. So I've done this table, and I've used the different Linux distributions on them. And I've compiled the kernel, because I need your kernel to work with the device managers, of course.
You need what?
I use the Chromium OS kernel.
Yeah.
But there's a Chrome OS and there's a Chromium OS.
Mm-hmm.
They're not totally the same, are they? Because at times I've had to get the recovery, just to figure out the times for them to compile or get everything to work. So how is the cycle between the Chromium OS and the Chrome OS? How is this?
They are built exactly at the same time. It's just that at the very end, the Chromium, in the Chrome OS image, we install the Google keys, so you get access to Android, and that's it. And then the icon is it's multicolor instead of blue. I think that's the.
If there's any vendor files, I think that I need something.
I don't think there's any more difference in vendor files. I think it's more that the code is signed.
And I've used the Chromium audio system.
You did what?
The Chromium CRAS, the Chromium audio system.
Yes.
And is there a future for this, or are you ever thinking of using Pipewire or something else than this?
I really have no idea, but I can check for you.
And I really struggle with it too, because when I read documentation, many times some bits work, and sometimes I get forwarded to Google internal documentation. It's been very fun, but it looks great, but sometimes I've been a bit lost.
Yeah, yes, but please open an issue every time that happens, because that's a bug. The problem is that when I work, and most of my colleagues, we work using the corporate notebook in the corporate network, so we don't realize these problems. So it's not on purpose, it's a mistake, and we want to fix it. So please report it, because sorry about that. It will never happen. It will happen again, but we will do our best so it doesn't happen. I can ask what are the plans for the Chrome OS audio system. I mainly work on the camera, so unfortunately we suffer a bit of tunnel vision. So yeah, so I can check.
No, thank you. You have great computers.
Yeah, thank you. Glad you like them.
Thank you for the talk. You mentioned about replacing the Raspberry Pi with Chrome book. Chrome doesn't have general purpose input output ports. How do I do this?
Some ones they have. They just need a solder station. The VTIO, they're always there. You just need to know how to solder it. But on the other hand, you have a touch screen and you have a nice battery. So of course, every device has its own, our battery can last a week. It cannot last 5 years. That's what you will use a different. So everything has a niche, and I think for home automation, I have seen many nice hacks with Chromebooks.
It's also built-in UPS.
Yes.
How do you ride that bike?
It's used to measure your strength against another developer. So when you have spent 5 review cycles and if you cannot decide, you need to one against each other, and we put fire on the two ends, and who dies loses. That's why we need to hire more people.
Is that an electric bike?
I don't know.
Only one side.
I guess the difficulty is how to turn it. But
Well, from what I understand, the Chrome OS is working on different CPU architectures like x86, ARM. From your experience, if you give a recommendation, I know that some vendors they like to work with community, some prefer to keep things more closed. If you rank, can you give us an example of the best if you really want to get a Chromebook and play around a lot and being able to say, okay, I want to change this and this and that. Okay, I can do it on this particular vendors, models, or architectures, and this specific architecture or vendor is very close, it's very hard to do anything, just need to use it as.
I think in terms of kernel, it's going to be very similar experience in all of them. I work mainly with cameras, right? And in cameras, we can see like 3 different trends. One is that companies that are completely upstream, and those we love them. The second ones, which they are like a mixed bag, where they start with a proprietary patch and then they hire somebody else to make that patch going upstream. Which means that maybe when you buy your Chromebook, the first 2, 3, 4 versions, you will have a proprietary, not a proprietary, a downstream kernel, another upstream module, and then it will be replaced by something that is upstream. And then we have a third ones, which they only want to provide a downstream driver. All the source code is always there. The source code has to be there, but it's not upstream. We try to convince as much as we want the vendors, and we even turn down platforms that want to go that path, because we want to provide 8 years support for your platform. So what happens is a vendor, they mainly care for you to buy the notebook today, and if they can sell you a notebook in 8 years, they will be happy. We want that to support that notebook for 8 years, so we have different agendas. For us, it's very important to maintain the product. And I think that's why Chrome OS platform is very nice, because you have 2 different agendas, maintainship and performance and capabilities working hand by hand to develop something. So I can tell you the notebooks that for camera, because that's the area that I know that are in these 3 categories, and we can talk about that later.
There is, in Android world, there is a Google SOC. Will it be a Chromebook with something similar to that?
I have no idea.
Chromebook was there a while ago.
With Google SOC?
No, it was not a Google SOC, but it was a Google laptop or a Google Chromebook.
Qualcomm SOC.
I don't remember actually.
There's too many managers between me and Sundar, so I don't know that. But thank you very much for the question.
Well, judging from how they're going right now, it sounds possible actually. But that also means that it would be Samsung based.
Samsung is doing the SOC, but it's Google and it has
the cores are so the original design is from Samsung, and Google has done some small changes.
Let's talk about running Android apps with this VM thing.
I don't know. So what I know is about Chrome OS. There used to be something called Arc++, which means running Android as a container inside Chrome OS, and now we are moving towards RDM, which is running Android inside a virtual machine in Android. I don't know in the other work how would that work. Sorry, I'm mainly interested in kernel. So
I was just going to say that's also interesting because Android is also moving to upstream first. So eventually we'll have the same kernel.
yeah, that's what we. And then I think Greg K is doing a great work there, convincing vendors that. But so specifically talking about multimedia, is very different multimedia in Chrome OS than in Android.
So how many times do you upgrade the major kernel version on the Chromebooks?
I mean,
This is 8 years.
so it's a lot of time. I don't know the specific for every platform because we have PMs which decide that. But the idea is to maintain the lesser kernels as possible across the different platforms. So that means we move pretty fast. If you tell me a specific device, I can tell you which is the calendar for that one. But we go as fast as possible. It's in our own benefit.
And do you know how much testing is performed when stepping to a new
It's hell.
version on that specific hardware?
So what happens, I don't know if I can tell this, but anyway, delete that, stop recording. So what happens is that
We make a new model. So for example, if we work, we mainly work with code names, right? So this is a laser. So we work, if we are going to upgrade the kernel, we make a new model, which will be called laser task kernel next. We work there, and we treat it exactly as a product, which means that developers get a daily report saying, hey, there has been this number of crashes, these crashes are growing. So we treat it exactly as if it was a model. We release it to testers, we release it to Googlers, we release it to companies that test, and then we make the upgrade. So testing, I think if there's something, if you can forget everything about the presentation, the only thing you cannot forget is that if you want to keep your products with the latest kernel, you need to invest a lot in testing. And that's going to be the best investment you're going to do.
The kernel sources, you can scan, you can look at them, but it seems that sometimes there are some backward drivers.
there's one.
So, I mean, some downstream drivers. And if that driver has been upstream with a completely new path and device tree, compatible string and everything, I was curious, sometimes it might not be obvious if it's not the people who was working on that you might forward port your backward patches without realizing that there is actually upstream driver available once you upgrade to the new one.
We have a quite big team in kernel, and a lot of maintainers work for Google, so these things are difficult to happen. What I like the most when something happens, so for example, Rockchip, we were using a downstream version of Rockchip camera driver, and then we worked in a new upstream version, and we changed it. And the great thing is that nothing happened. We didn't get more reports. We didn't get more errors. We just by looking at the performance report, we saw that we get better performance on those specific notebooks, but we didn't get more bug reports. Nobody noticed. I was so happy. No news, good news. And that's just an example, but there's many times that happens, that we replace something with something more open, and nobody noticed. So that means our testing has been working. Yes?
How do you get those reports back into statistics?
So when I was going to tell you a joke I told to my grandmother, to my mother-in-law, but no, I won't because it's recorded. So when the Chromebook crashes, you get a pop-up saying, "Hey, this crashed. do you want to help us send me some reports? And you can also send a report voluntarily. I think you need to press Alt, Shift, and I, and you press it, and then you send a report. And if you put hashtag Ribalda, I will read it. Don't abuse. Yeah. Yeah. Yes.
This security chip you mentioned, so is that something that is the same for all Chromebooks, or is that also vendor specific, or who develops that?
So it's me. I mean, there's a very minimum which all the Chromebooks have, which is handled by a chip called CR50. This security chip is something that the source code is there. It's nothing magic. And it's doing this, I was telling you about the CCD, close case debugging, where you need 2 minutes access to the device before you can manually. It also has access to the keyboard and all these things. And there's another part, so the bootloader, if you look at ARM, sometimes it starts with a secure boot from the vendor. So ARM, they have their own solution for starting in a secure way, and then continue. But at the end of the moment you enter core boot, from that moment going on, everything is the same in all the Chromebooks, as far as I know.
And
But
the
before
chip
Chromebook,
it's developed by Google, the chip, or?
the CR50, yes and no. I think there's a chip which is developed by Google, but then you can use any chip and install Tyson. There's a Tyson version of CR50. So it's nothing. I mean, it's completely open. But as I said, since the moment it starts core boot, all the security is the same for all the Chromebooks. But if you want, I can double check with the security team, just to make sure I didn't say something stupid.
So I haven't used Chromebooks at all. Are every Chromebook the same? If you compare Android, you take Samsung Android and some other Androids, they don't look the same.
Mm-hmm.
But is Chrome always the same? And it's always Google that releases the software, not a
Yes.
software.
We build it, and we build it. I don't know if maybe there's a Chromebook that when it boots it maybe has a, I don't know if there's an API for getting a new welcome window. We call it out-of-box experience. I think there's an API where the vendor can say, hey, Samsung, or whatever. But besides that, everything is exactly the same. Nothing? One more?
I don't know Chromebooks at all. What's the Chrome part of Chromebooks?
So at the very beginning, it started with a very big dependence on Chrome, on the browser. So it was basically a Linux running a browser, and everything was a browser. It has developed a lot. It has evolved a lot from that. And I guess we keep this name. Yeah, and also I like the logo a lot. I think it was a good decision.
Does it pass kind of parameters from Chromebook?
No, you don't. So that's what I was. If you see the slide, it's depth charge, which is in charge of passing the parameters.
Okay.
And yeah, and if you want to modify the boot parameters, you write it in. You do this, and that's the way you tell depth charge the new kernel parameters.
And by default, it won't spit out the output on the serial, right?
No, by default, it will not. No, because so one of the no.
Right.
By default, we need to boot in 3 seconds. So if we need to write to the serial port, we cannot do it. That's why you need to pass this parameter at the beginning, so you enable the serial output.
And for a pre-built kernel, how do I?
Sorry?
For a pre-built kernel.
Yes. In pre-built kernel, I don't think we even have the serial port console drivers enabled.
No.
At least for x86, the TTIS0, the serial port, is not built.
Is there any chance, the new Chrome OS,
Sorry?
They want the
Fuchsia.
I don't know how to pronounce it. Is there any chance it's going to come from Congress?
I don't think so. But again, there's too many people. maybe next year is Fuchsia. Why is better than I don't think so.
Do you have a big community interaction, or are people actively helping Chromebooks, or people hacking and feeding stuff back to you that you know?
We have a lot of contribution, and so there's many parts in Chrome OS. Unfortunately for the HAL, that's everything above the kernel, I don't think there's much movement. But for the kernel, yes, there's some movement, and there's a mailing list for the Chrome OS specific kernel, which it's the drivers for our chips that are upstream, and that's where we post the patches before they go upstream. I wish it was bigger. The problem is that that's also a good way to recruit so many people that used to be community is not community anymore. Okay, so that's it. Thank you very much.